Hey class, Absolute 5 here. So today we are talking about derivatives. So the thing is, before I talk about derivatives, let's just recap something very quick. We've came across so many things in our lives of humanity when it comes to mathematics, where we first invented line segments or even just a ruler to measure things, to measure inches, feet, yards, or even cups of volumes of liquids, or even the temperature. And we've even made some form of measurements for even time. Now that's pretty interesting. Now, this concept I bring about is derivatives. So it's just like how I mentioned earlier, it's a tool to measure something. Now, a derivative measures a rate of change in any field of science, whether it be engineering, physics, chemistry, and even economic growth, depending on how something grows, depending on how fast the rate grows. So this technique is very, very important. It seems very confusing at first when you're introduced to calculus, but this is one of the main crux, the main heart of calculus. So understand that you really need to understand. If you're taking a calculus course right now, this is something that you really need to understand right now about how to measure something. So let's get right into the definition of what it is. What is a derivative? So definition. The derivative of a function f at a number a denoted by f of a is the limit as f of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Now what does this mean? One last thing. If this limit exists. Now what does this mean? If the limit exists for your function, depending on whatever it is, you can take the limit as h approaches 0 to whatever your function is. So this is just telling you, you need to plug in whatever your function is, a plus h, and you need to plug in f of a, plug in that input of a, and then subtract both of these two, and you divide by h, and also take the limit of whatever function this is. So this is a very interesting concept when you're dealing with this. I know I mentioned this in the last video, but this is a real work of art that when you first see it, you first have a headache about it when you first see it. But then when you get to know it, it's actually pretty amazing when you actually see it. So let's do an example to see how do we apply the derivative of a function. So let's see, what's our example today? We take, the example is find the derivative of the function f of x is equal to x squared minus 8x plus 9. So pretend this is like your business model or your function or your behavior, depending on whatever it is. After you take the derivative of it, that tells you how much has it changed. That's the rate of change, how fast is whatever it is that you're using as your function to change. So again, we're going to apply the limit as h approaches 0 of f of x is equal to f of a plus h minus f of a all over h. So let's do the first case. What is f of a plus h, right? Wherever I see an x, I'm going to plug in an a plus h. So parentheses a plus h is getting squared minus oh, I made a mistake. It's actually plus. Sorry. So this is 8a plus h plus 9. And then if you do the arithmetic here, if you expand this, this becomes a plus h times a plus h. You get, again, like I said, a plus h, and you can distribute here. So I get 8a plus 8h plus 9. And after you follow this out, you get a squared plus ah plus plus h squared and plus 8a plus 8h plus 9. So I'm left with, I'm going to put with my result on this side so I can plug it in later. So I get a squared plus 2ah squared plus 2ah plus h squared plus 8a plus h plus 9. 8h, excuse me. So this is our f of a plus h. So let's leave this to the side. So we're going to erase everything over here. Okay, so now let's find what our f of a is. So my f of a is simply my function, which is a squared plus 8a plus 9. I then get a squared plus 8a plus 9. So then, now I take the limit as h approaches 0 of f of a plus h minus f of a all over h. I get a squared plus 2ah plus h squared plus 8a plus 8h plus 9. So now I can erase this part since I used it. Minus my f of a, which is right there, a squared plus 8a plus 9 all over h. Okay, so now we need to do some cancellation. So first let's distribute the negative sign here. A squared plus 2ah plus h squared plus 8a plus 8h plus 9. So now I distribute the negative sign on the right side. I get negative a squared negative 8a minus 9 all over h. So now you're going to see there's going to be a huge amount of cancellation where in a squared cancels with the other a squared. 8a cancels with the other 8a. Negative 9 with the positive 9. So after we clean up some of the algebra here, we're left with what? We're left with the limit as h approaches 0 of 2ah plus h squared plus 8h all over h. Remember, when you do the limit, it's, if you plug in right away, you're going to get 0 in the denominator. We can't do that, so we need to factor out an h in every single term. So after I factor out an h, right, what am I left with? The limit as h approaches 0, factor out an h in each term, so I get 2a plus h plus 8h, this h, excuse me, all over h. The top one and the bottom one cancel, so I'm still left with the limit as h approaches 0, 2a plus h plus 8 I'm able to use the property of limits to just go straight to the h. So I take 2a limit as h goes to 0 of h plus 8. So I plug this in, I finally get what? 2a plus 0 plus 8, and that's just simply 2a plus 8. So this is how whoever started calculus, I'm not going to get into that debate, but just the fact that we are able to measure the rate of change through this method. Now, there is an easier way to do limits, well, derivatives, I should say. There's a much easier and faster way. I will get to that at another point in time in the future. But for now, when you're doing derivatives, you're doing it the long way by taking the limit of f of a plus h minus f of a all over h at the moment. Now, again, like I said, this is something that is a headache when you first see it, but then later you get used to it and it actually becomes easier to understand, because you're measuring something that's rate of change. It's kind of like a new skill that you gain when you do calculus. That's what I feel like when I do calculus. From my personal experience, that's how I feel like, because when you do algebra, you're only really like manipulating things into your own way rather than being able to track something, being able to use it as a form of measurement, which is very, very powerful, very powerful. So that's the lesson for you guys. I hope you enjoyed it, and be sure to like, share, and subscribe to this channel. Leave a comment down below to let me know how I did in the video, and be sure to hit that bell button next to the subscribe button to get more content from me for more math videos, of course. So this has been Absolute 5. I'm Roger Palomino, and math is infinite because there is infinitely many possibilities.